Hey guys, so today what we're going to talk about is the difference between what we call an arithmetic and a geometric sequence. So before we move forward, let's just define those two things. Alright, so the difference between these two things is if I'm dealing with an arithmetic sequence, that means that each number is increasing or decreasing using addition or subtraction. So in this example here, we've got an arithmetic sequence because it's going to take the previous term and add 3 to it. So every number is just going to be 3 larger than the number before it. So we'll have an arithmetic sequence. So let's do that first example. It says the following is an arithmetic sequence. Write the sequence defined by f of n in subscript notation. So the first thing I want to introduce you to here is that this is not the only way to see this written. We could have it written like this instead. We could just have it in subscript notation where n is just a little subscript. And the reason that I'm bringing this up is because it's just another way that you could see this written. It doesn't mean anything different. But sometimes these sequences are written this way. And then it just says to find the first 3 terms in the sequence. So in order to do that, I'll need the first term. Well, I know that f of 1 is 4. But to find f of 2, I'll need f of 1. And I have f of 1. That's 4. So f of 2, or f sub 2 is 7. So that's the second term. And then the third term is just going to be the second term plus 3, which is 7 plus 3, which is 10. All right, so that's just an arithmetic sequence. Today's lesson is just all about knowing the difference between these two things. You can see the difference here from this number to this number is 3, from this number to this number is 3, and that'll continue to happen one number after the next. The difference is always going to be 3 from one number to the next. Okay, let's talk about geometric. So geometric sequence, as I'm sure you guys have already recognized, instead of increasing and decreasing by addition and subtraction, now it's going to be using multiplication or division. And this is going to become important in a couple later lessons because geometric sequences require a little more care to deal with than these arithmetic ones because they're a little more complex. But still, this is a geometric sequence that's pretty simple. You're just going to take the previous number in the sequence and multiply it by 2. That's really the only thing that's happening here. So let's write it in subscript notation. Instead of writing g of n, I'll write g sub n equals 2 times g sub n minus 1. And I know that g sub 1 is 5. My first term is 5. So let's find the first 3 terms. The first term is 5, that's given. To find the second term, because we're dealing with a recursive sequence here, we have to have the term before it. So I'm going to do 2 times whatever my first term is. And my first term is 5. So my second term in the sequence is 10. To find the third term, again, I need the term before it, which is 10. So my third term is 20. So what you'll notice now is instead of these all increasing by the same amount, that amount is going up every time because it's a geometric sequence, so the common difference is not the same. And E just says for some number t, for the first 3 terms of an arithmetic sequence are these 3 things. We've got 2t, 5t minus 1, and 6t plus 2. What is the numeric value of the 4th term? So here's the key here. This is why we need to know the difference between arithmetic and geometric. Because if it's arithmetic, we know that the common difference between each of these is the same. So the difference between 2t and 5t minus 1 is some value. And this difference is also going to be that same value, as will be the difference between 6t plus 2 and the 4th term, right? So the common difference is always going to be exactly the same. So what we've got to figure out is, what is that common difference? In order to work at finding that, let's just use what we know. I know that if I take 5t minus 1 and I take away 2t, that should give me this difference, right? The difference between this term and this term is some number. And I know that that's the same as the difference between this term and this term. So all I've done is I've said, I know that if I subtract these two things, I'll get a number. And I know that if I subtract these two things, I'll get a number. And those numbers have to be the same because it's an arithmetic sequence. So let's solve this and figure out what that number is first. What is t? Just some quick algebra. This becomes 3t minus 1 over here. This becomes t plus 3 over here. And this becomes 2t, this becomes 4, t becomes 2. Just some quick math. So now I know that t could be 2. And I'm going to use that to figure out what these three terms are. If I know that t is 2, well then that means that my first term is 2 times 2. So my first term is 4. And my second term is 5 times 2 minus 1. So my second term is 9, and my third term is defined by 6 times t plus 2, so it's 14. Notice, because it's arithmetic, the way we can check here is we can see what is this common difference. Those are 5 apart, those are 5 apart, so we can naturally assume that our fourth term, which is what the question is asking for, will be 5 apart as well. So what number is 5 larger than 14? 19. All right, so that's just using the definition of an arithmetic sequence to try to solve a question like this. This is a very common core level question. There's a lot in here. You need to be able to algebraically solve for a variable and set up an equation that you can solve too. They haven't given you this. You need to reason this out and then solve for t. And once you've solved for t, it becomes pretty easy. But this is the important definition here. So if I were you, I would make a note over here on the side to define, or to at least recognize why we used this method over here. I would say because it's arithmetic. So it's arithmetic, therefore the difference between terms 1 and 2 equals the difference between 2 and 3. And of course 3 and 4, 4 and 5, right? This won't change. All right, nothing too crazy today. Just defining a couple different types of sequences, and tomorrow we'll practice. We'll have some basic ones like this where I'll just be asking you to define some sequences, and then we will do some of this as well. All right, I'll see you guys tomorrow.